Or no, it's better known as Perl. It's Perl and monitors.
This is a test of the sound.
I guess it's.
Testing 1, 2, 3.
Okay, working. I don't know what, but it works for a little.
I'm actually impressed.
Good morning.
Like I said, I didn't. Yes. No, you travel with non-zero levels when you go. Sign up with the very end. Because among other things, as a long run, you get access to free
Wi-Fi and the better.
Yeah. Like it doesn't even cost anything. That's why it's like non-zero amount of travel. You should definitely have
Well, I mean, you can use them.
It's great. Right. Well, that's just it's running.
It's XFCE.
Yeah, that's the first part. Well, then why did you pick XFCE? You wanted to play that?
I was using GNOME and
I'm not gonna.
So what do you like?
I like it.
I like it. So I used to be not go on. You would never.
They just fixed that 5 years ago. Because they completely rewrote the whole thing. The beta is out now. Give it a shot. Like, boot up your live media, and see if the docking situation is improved.
I'll try it.
Because if it hasn't, these file bugs, they really don't know.
So
That was the whole point of them rewriting all multi-monster.
we'll use it. So it's not even a
Sure.
It's like a good there. I'll probably be changing. Probably next week. I've got to go.
The only reason this thing is no is that that's what.
We're getting an English thing now. We're getting it clear. We're just not using it on the screen.
It's called.
So this one.
Right. So my new solution is get that.
There's also this remote for the projector. I don't know if it has inputs or something. I don't
might be.
want to mess with your stuff. I don't want to be
I
helping.
mean, it's as much
But-
your stuff as ours.
Okay.
HDMI.
Huh. So
I'm very
HDMI. I think that means no HDMI signal either. Let me see.
Power button. And
Computer.
I know.
Is there anything changing if you unplug it?
Yeah, I can see the difference. Sean said that he can see it in that.
Yeah. Can you still see the stream? Yes. Okay.
So I should be sending it fine.
If you unplug, that's this reaction.
Okay. Nope.
Search.
And then okay, there's just one HDMI. That must be it, I guess, then.
Yeah, that's okay. Except for in Windows, so
Oh,
it's back up if your Microsoft Suite is.
So screw that.
Yeah, but on Linux, it's just out, so it's on.
but are you sure it's not like,
Well, Sean sees it.
yeah.
There's nothing you can do. It's just an iPad, so there's
Yeah, true,
literally no
that's
such
true.
things. And Sean sees
Yeah.
it, but I saw there's HDMI. Maybe you need to put it on HDMI, but
Yeah, I mean, here, if you go like search,
yeah.
it says,
Oh, the top one, that should be it.
yeah, but I tried it already.
Oh,
No, you're gonna stay right here.
It's like,
yeah.
it says coordinator is on. So it's probably connected.
Oh, that looks like VGA.
Yeah.
Try the HDMI. That was at least. Huh. And it's supposed to be going to here. Yeah.
That is the one that's going to Sean.
I see it back there.
It's just an iPad. It should be something.
You've got signal coming out
Yeah,
of here,
okay,
going to
okay.
the splitter and going
Yeah.
through that. It's just this.
Yeah.
Yeah. There's a
Did we unplug this?
computer.
Unplug it back in?
Right, that was the.
Yeah, I did look at that, okay. And there's like,
This, we just tested this before you came too, and this was working, so.
Hmm.
can we test with a laptop? But I mean,
I don't see
it
why.
should, yeah, it works because you get the stream there. And that takes that out.
Hey, the projector doesn't work. I'm sending signal to the stream.
Uh-huh.
Yeah.
I know.
The stream is getting it. Yeah. Yeah.
The same thing happened in Boston, with like HDMI splitter and the.
Can we just ask everyone to play the stream on their phone, and I'll be just giving a
Yeah.
talk, and then they're just
Everyone
watching
pull
the
up the
slide.
live stream when it
Yeah, yeah. If you want to, but like, there shouldn't be anything strange about this thing. If it works for you, I'm gonna scream.
10 minutes ago it was.
All right, just yeah.
he tried like 3 times.
They're getting this thing bad.
He said,
We're not getting it.
oh yeah, everything.
HDM.
Now it works.
Yeah.
Oh, that's your problem. You use a Red Hat Enterprise Linux.
No. I do. That's the reason why it works.
I have an iPad, that's the problem. Okay, so I'm taking it.
Mystery, because it works. from
It
the
works
iPad.
there.
No,
It works through the stream,
Yeah.
but not to the project.
The
And if
resolution,
I-
maybe.
There's no setup, nothing. It just works. Okay, so it just doesn't understand this thing.
So what is your slide? Do you have a PDF? You want me to
I can
lend you that?
Are you sure
get
that,
you.
can you advance the slides? I mean, it's like,
Yeah. It's just weird. I wonder if there's something. No,
I mean, it should give you the desktop.
it should. No, this always works fine. This is literally the first time it doesn't
But
work.
it worked with your,
Yeah. Okay.
so then there's nothing wrong with the project or itself.
Probably.
I mean, unless it's refusing the.
Okay.
The
Can
resolution or
I?
the frequency rate? Do you have a PDF?
Yeah,
Can you
yeah, I
make a PDF
can.
out of it?
I can.
Uh,
I somehow can. This is what happens when you're using an iPad to present about. I don't know how to give you that. It will not do what you think. No. It will not give you that. I need to. Sorry, what? No, I need to figure out how to make it. I don't know how to make it. Oh, export. This can do it, this can do it. No, don't touch it. I'm fine. So export email to. Oh. Yeah. Then we come from where his iCloud address. Oh, but it doesn't go there. This is so annoying. All right.
I know, they're wrong.
Yeah.
I'll give it like one more.
Otherwise, you're gonna freestyle.
No, we went to CentOS, I didn't see it. Then we like start and the webcam we had and then we oh, all right.
basically has to interpret it.
Oh, yeah. I have two located and you have
The reason why they're expensive, it should be another application. So. Yeah, but like you never know. For example,
Okay, my name is Fernando, that's fine. Well, okay. It's fine, you need to duplicate it, I will just track it here.
I don't know what it is.
I don't know how it's reached.
Because I wanted to be able to grant.
Yes, there's like a slideshow. Yeah. Nice. Okay, okay.
And while I.
Hello, 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 hello.
Yeah, that one. No, I want this one. I'll be.
So I patched it. Because the patch has been sitting open in the syntax.
Okay, I think it works. Should I just start? Yeah, 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 yeah.
Now you owe me at least
I owe you something, yes. I hope your battery is going to run out. No, it's not.
Yeah, it was charged. So
Yeah.
it should be okay. Touch wood, please. Yes, yes. Because my phone when I was 45 minutes after. So I should just ask. And
But the stream was hitting it, just the project that
yeah, but in the resolution or whatever.
something, I don't know what it's doing. I hate such a thing. Maybe it's kind of like,
Especially because if people saw that it was working with trolling on social media.
oh, I hope so, yeah, that would be amazing.
Adding the depth package to CRV. I do have it tomorrow. Updating the GA.
I don't know why they want to be late because we are already late. Oh, they want probably to stream that out or something.
Yeah.
Oh, that's also this.
It actually, I'm just going to.
It's fine. We could play a game, we can do slideshow karaoke. But his slides on the iPad only, so we don't need to.
You know what? You just said it again. You send me that link and then we can try that as like a social thing after.
Although that needs to run on the iPad, because like schedule and everything needs to be.
So that means that during lunch break, we have just enough time to figure that out. And solve the problem. Maybe we can do the now. Yes, it can be fun. So you know, it's like investing time to do something fun. It is. That's why I'm trying to prove it, that it's really worth the investment.
Oh, come on.
I made a slide like 7 years ago, so my job is not as
Yeah, because these are the same one that you guys just reuse on the site.
We should
Oh,
do
no.
that. It's like generate slides on the fly. Actually, not only that. You know, it's AI generated slides. The next slide should
Yeah.
Are you ready?
I think so.
I'll not waste time
Yes.
with pleasantries and why don't you just, because we're 10 minutes over, so.
Okay,
go ahead and start the show.
no pleasantries, just my talk. All right. Hey everyone. So this went perfectly, but here we are. So my name is Adam. I'm the CentOS Stream lead. I sort of do CentOS Stream for a day job, and I work for Red Hat. This is my first talk after like 3 years of pause, so this will be interesting. Having 2 laptops to do the slides because world is beautiful. So okay, so CentOS Stream. What I want to talk about, actually, let's go back. I forgot how to do talks. So we're going to talk about 2 things, mostly how we Red Hat do our work or how we get work done to make RHEL, and then how you can get involved and use that to participate. And this is basically the goal of CentOS Stream. This is the state sort of before Stream. So everything started in Fedora, and they keep innovating and doing package rebases and all sorts of weird stuff. Once in a while, Red Hat takes portion of it and it goes through a very complex process, and we get enterprise. And then we rebuild so that's that. And we did between we sort of put basically 2 new things to make the steps slightly smaller. And the stream. So Fedora is mostly Fedora, right? Nothing change. But we do a continuous rebuild subset, which is Fedora ELN. So we'll test the preview of the next major RHEL version. So right now, if you go to Fedora, find Fedora ELN. This is basically RHEL 10. Right now, it's been done for years. 1 year, I don't know. That doesn't make sense. CentOS Stream tracks the next minor RHEL version, and this is where all the development happens. And this is really, I can even show the next slide, which shows it slightly better. But yeah, these are all the differences. There's like Fedora sources. These are RHEL sources. And I will show you in a moment that the CentOS Stream sources and RHEL sources are basically the same thing for most of the time. And we even internally, like in our development guide, we sort of talk about these 2 as the same thing. CentOS Stream is really like the development place for RHEL. So you can really, and everything is available in public. So like you can see how things are going. So that was just like an introduction, Fedora ELN, CentOS Stream, and let's get into the details of Stream, how things flow. So this is a diagram I made, and I had to fix it a little bit. It's sort of complicated, don't worry about it. It just shows basically that everything starts with Bugzilla bugs, and we do merge requests into GitLab. This is our Git repo with sources. And you can see it gets immediately synced internally and then goes through a build process. There's a build in CentOS Stream Koji that you can see, and build happens internally and goes through various tags that I'll talk about. Basically, build lands in one tag, then it goes through gating, which is like a testing, goes out to a development compose, and then goes through verification, which is mostly like internal process paperwork and all sorts of stuff. And then it gets to the product, but also to the production compose. What is a compose? Compose is many things. We basically take a snapshot of all the builds and make a YAM repository, make an ISO that you can install container images and all sorts of things. Basically, it's how you get any distro from this universe, Fedora RHEL CentOS Stream. And let's have a look how it actually works. So I said everything starts with a bug in Bugzilla, and this is someone added multipath TCP. This is like half a year ago. There was a bug in Bugzilla. Then they made a merge request. Again, you could see this. And that got submitted as a build to Koji. This is the CentOS Koji. And yeah, you could follow it all over, like as it goes. If you scroll down, there were the tags. They're like all the gate, pending, candidate, what I show you as it goes. So you can even monitor that in there. So it basically did all these things in public, and you could see it way before it gets to RHEL. So I think that's cool. So this was the flow, and let's talk about contribution. So starting with RHEL 8, Red Hat publicly said that they're going to do new minor release every 6 months, a new major release of RHEL every 3 years. And so you can build some expectations from that. And also, we do some, this is ABI, we do some promises to our customers about RHEL around ABI guarantees and support statements and whatever you would expect from an enterprise operating system. So taking these into account for contributions, what can you do? So bug fixes, these are very easy. Don't break what customers expect, and if you find a bug, you can fix it, and we just review it, run it through some tests, merge it, and it's in. There's stable updates from upstream. This is a tricky word. Well, not tricky word, but as RHEL gets older, it gets different from upstream, right? It lives for 10 years, and it sort of diverges, and because we have these promises, it gets slightly tricky. Like, we can't just accept any change. Some packages rebase, some don't, but if there's, so that's what the stable means. If it doesn't break the promises, we can just take them, and that's all great. But most new features are backported, which is an interesting thing. You basically just take a feature from a newer version and put some work and put it in the old version, so you have the feature but don't break anything. And this is how a lot of features happen in RHEL as well, and in CentOS Stream. So these are the contributions. What we can't really accept is the changes that break an ABI. And by the way, there's a document called the RHEL Application Compatibility Guide. You can read, you can find it online. Most packages have the same ABI for 10 years, so for the entire duration of RHEL. And we take it seriously because customers build their apps, build their applications. They don't want to change them and want to run them forever. So we take this very seriously. So please don't break ABI with the contributions. We would need to politely say, no, explain, and close it. But okay, next. I say maybe docs, typos, man pages. If you're a customer and you have a bug in documentation, and you can find in customer portal, report issue, and get it that way. Otherwise, we can take these, but we tend to batch them. And so if you open a bug fix, might get merged, but it might take some time to actually get in because developers are busy with actually code changes and stuff. But yeah, this really depends. And also wanted to show you, this is the life cycle of RHEL. As I said, it's basically 10 years. We do minor version every 6 months. And there's also, the minor version does the dark blue. We also have something called extended update support and update services for sub solutions, SAP. And then the last one is sort of longer. And if you look at Stream, there's like arrows, and Stream somehow like lives there. So for Stream, you can mostly ignore this, and like it follows that, and once in a while, maintainers just take things into the next minor release. And we have this same thing for RHEL 8, and there's also RHEL 7. There's a lot of things going on. But yeah, just for reference, there's also no way in Stream to communicate like which minor version it is. But if you really need to make sure something lands, just talk to the maintainer in your Bugzilla and maybe you can figure it out with them. Okay, so that was like what contributions go to stream, and this is how. This is just a few obvious things. You can open bugs in Bugzilla, you can test stream, you can, if you find something that's broken for you, you can get it in and it's much better than before, like you can get it in maybe the next minor release. You're also welcome to open merge requests. Just, we would ask you, please open a bug first, talk to the maintainer, and that's a great way to contribute. And if you do contribute, this is just from the diagram again. This is how you can follow your change. If a build lands, you can see this in stream Koji. It goes through these tags and then passes the test. You can get it, and then the production compose we do manually, like every week or so, based on how healthy the development compose is, which mostly is. So every week or so we get a new production compose. And you can get these on composes.stream.org, or you can take the packages from Koji if you want to really test them earlier, but otherwise they will show up here. All right, let's talk about how you can use CentOS Stream. You can use it to preview features that might be coming to RHEL or are coming to RHEL. Try them earlier, see if your stuff works. You can submit patches, file back reports. And if you build on top of RHEL, if you have a project that builds on top of RHEL, you can use CentOS Stream in your CI to get an idea of what the next versions might be or should be, and you can get some results that way and get fixes landed much earlier and be ready for the next RHEL. We also have SIG, special interest groups, and many of them are here. There'll be talks throughout this conference as well, FOSDEM. They do their work in CBS, which is the Community Build Service, a build system. And Stream lives there as one of the build routes, so you can definitely use Stream in there and work with the SIGs. And also you can try their content on CentOS Stream. Okay, so this will be a short wrap up, or like short, I lost the word. Anyway, we're going to talk about what's next. So I showed this diagram, Fedora ELN, CentOS Stream, and Red Hat Enterprise Linux. And with RHEL 10, we're basically here. So if you want to contribute towards RHEL 10, push your changes to Fedora Rawhide. You can see them in Rawhide, but also you can see them in ELN, rebuilt with the RHEL flags, which is like closest to RHEL as we can get right now. And later, when we're actually, this is from 9, so this is not 10, but like I can demonstrate it on this. Just to explain, you can see Fedora Rawhide branch. This is like where the development goes. There's very frequent ABI rebases and stuff. We rebuild ELN there as well, and then we do something called Bootstrap, which like we branch CentOS Stream 9, and then start building RHEL from that. And I actually have a better picture I just took a photo of. No, it didn't make the slides. Okay. You can see it on papers there, but basically the RHEL line started like somewhere there, and it demonstrated like 3 eras of RHEL, sort of like, right now with 10, we're in Fedora ELN, you can contribute mostly anything that you can in Fedora. Then when we branch CentOS Stream, but before we ship RHEL, there's still possibility to do like ABI changes. But after RHEL ships, which is currently 9, we no longer can accept ABI breaking changes. So these are like 3 different states. So 10 is in the ELN state, 9 is well over in the proper state. So yeah, this is where you can get sources, contributions to 10. But that's mostly it for me. Some useful links, and I would like to take some questions or discussions. Thank you.
If anybody has any questions, we have a mic to pass around.
Yeah.
Yep.
Absolutely. I'll give you the mic.
Yeah, for the recording, we need the, yep.
So before Fedora ELN, you used to freeze in a specific version of Fedora, and then you take for CentOS. So how this will be different than ELN? I assume that ELN, for example, for RHEL 10 will be Fedora 40, 38? 6 releases from now, yeah. So you will freeze Fedora Rawhead to be Fedora ELN, and then you will take Fedora ELN from there, right? And then Fedora ELN after release 10 will continue getting Rawhead again from Fedora.
No, so rawhide is, I can show you the diagram again. So rawhide is, ELN is always tracking rawhide. So that never changes, but we branch CentOS stream from that. So ELN is always, basically the moment we branch CentOS stream 10, ELN becomes RHEL 11, sort of.
Whenever you need to have any minor versions changes in your RHEL. Correct?
Yeah, then for stream, yeah, yeah, these are like you can see the arrows, like we can pull some changes to CentOS stream after Fedora branches, but not all of them. This is manual process, then like we choose what we would get. Yeah.
Yeah, it works. So why CentOS stream it's not following the end of life cycle also as RHEL? I mean, it's around 5 years, right? But we have 10 years for RHEL. What happens? Why is this gap between 5 years of difference between them?
I guess you might be referring to this. Right? Yeah. So stream. The goal of stream is to contribute to the next minor version of RHEL, and that basically goes up until there. But then there's like no really new minor version like happening. I don't have a good answer for that. Actually, Alexander has. Yes.
Yeah, I mean, I know that that for instance for 9 it's up to 2027, right? Which is
Yeah.
9.10.
There's a much smarter person than me to answer the question.
First of all, there's still like slight discussions happening in the background. What will happen with that 10 part, and maybe something will change. But we need to understand that like what happens with CentOS Stream is that we made CentOS Stream part of RHEL engineering responsibilities. So CentOS Stream becomes the overhead on RHEL engineering. For every change they do, they need to care about CentOS Stream commit, they need to verify it, test it, and so on. We do as much as possible to remove that overhead, to reduce it to the minimal step, but it's still an overhead. And of course, like RHEL engineering considers trade-offs which this brings, and supporting it for 5 more years, it's a lot of work as well. And of course, also we are in position that we want to bring people forward. We don't want actually people to sit for 10 years on something while we're already developing 11 and 12 version. We want to encourage people to move with us together. And that's why, like, I personally, I believe 5 years support cycle is enough for many use cases. Some people will find counter examples, for me, of course. But also, like with CentOS Stream, we brought in a year and a half before of the release, the supported life cycle. So you should onboard to CentOS Stream earlier, and you should offboard and get on the next version earlier. And like it's for the best of the community, for the best of use of our resources, and it's like I think it's a good thing in the end. So that's my take on it.
And just to add something to what Alexandra said, for me, normally 0.0 versions of RHEL used to be not good. And since Stream is public, 0.0 versions are actually usable.
Are there any more, were there more hands up that I thought Neil?
How do you figure out who the rel maintainer actually is to talk to? Because there is no way I have figured out in 3 years of doing this how to figure that out.
That's a great question. No. You mostly can. So like, if
Because
they're
I
looking,
can't use the Fedora maintainers as a guideline for this.
no,
either.
you can't use the Fedora maintainers. If they're rel people, like that sometimes match, but like that's one way you can do it. If the Bugzilla gets assigned, or you can talk in the Bugzilla to the maintainer, that's a way. But yeah, I don't think there's really, yeah.
Assigning the Bugzilla doesn't work because a bunch of teams redirect Bugzilla to dev null. So I had this happen before where I file a bug against something and it gets assigned to null, literally. And when I find this, I file bugs and it gets eventually fixed, but that's not ideal. The trick I've used is look at the committers on GitLab, and sometimes that works. Oftentimes the committer is one of 3 people, and then I just bug them. But like I know them, so I don't think a random person that outside of the project would like to contribute would feel comfortable doing that. Maybe we can get a list somewhere. Like that would be really nice. So to have a service where we can look up contact for a package like we have for Fedora.
Yeah, Alexander might give you some answer again, but like, I'll give you sort of non-answer. What I'm working on for L10 as well is like there's a tool called content resolver where you define the content set, and like I'm at least mapping rel subsystems to the packages, and I would love to get the maintainers there as well. So you should see it, but this is something that's in progress. Alexander.
Yeah, so from perspective of rel engineering, the official way is Bugzilla assignee. And if it's assignee is a person, this means it's a person and who is responsible for maintaining the package. And if it's a mailing list, it may be a group of people responsible for this, because like in rel, there's not always one person per package. There's some distribution of load between teams, and there are like subsystem teams responsible for development. If you say this doesn't work, this is good feedback. And one way to bring this feedback is to the working group. I don't remember exactly how the full name of this working group. The one which is where Josh Boyer is, Brian is there. Yeah, and so basically there is a CentOS SIG about like a rel collaboration and rel features, and you can escalate things there if they don't work. But yeah, in rel we don't have single person always responsible. There are teams, and this makes sometimes responsibilities not clear and sometimes lost. And definitely, if there's no proper assignee in Bugzilla for a component, it's a bug. And like content resolver work, which Adam is doing, actually helps to fix these links and have this information in the right place.
So we had a question in the online chat. Question of, oh my God, even with glasses, I can't read. Is the packaging Git repositories in Fedora and CentOS, are they going to be linked? Is the question.
Sorry, say again.
The packaging Git repository of Fedora and CentOS are going to be linked? I'm sorry, I can't elaborate. I'm just the messenger.
Oh, okay.
Yeah.
So if
yeah.
Oh, like one repo for Fedora and CentOS. Oh, you mean like this Git? Okay, I guess I get the question. Yeah, sorry, I'm not slow. Just take time. Yeah, the question was if we think about one source repo, user repo with branches for Fedora, CentOS, StreamRel. I don't think so at this moment. Although there's many things moving to GitLab, so maybe that could happen in the future. But I don't think I've seen discussions about this.
Okay.
Alexandra again knows more than I do. Why don't you do the talk?
So yeah, sorry, I will just keep going. The thing is, Fedora and CentOS packages, while we use snapshot of Fedora state or Fedora ELN state to bootstrap CentOS, we still add changes and they're not the same. So while there is a sync process, it's not exactly like the same Git history of every package. There are some changes which are applied on top, and CentOS and Fedora packages not always share the history or not even share the like branching approach and things like that. So they are kind of linked at the bootstrap process, but not after that, right?
Right. That's maybe I understand the question a little bit more even. Like yeah. Yeah, on this bootstrap diagram, like yeah, they're basically the same thing for ELN and Rawhide. Then when we bootstrap, we pull changes, but they diverge so much. So yeah, it makes no sense to like keep them in sync. But there might be still things getting pulled in.
Okay, I think in the interest of time, we should move on to the next one. So thank you, Adam.
Thank you.
Next up will be Jack talking about the Alma Linux build system. So Jack, as soon as you're able to get hooked up, let's just go ahead and start. Awesome. Okay.
Yeah. Thank you.
Again, someone needs to review a
Everything going? We're good on the stream?
We ready to go, Sean?
Looked good here. Yeah, go ahead.
All right. Good morning, everybody. I thought the highlight of our week would be visiting a particle accelerator, but this is definitely got to be it. So good morning, everyone. I'm Jack. This is Javi. We both work on Alma Linux, and we'd like to talk to everyone about some work that we've been doing, pioneering work around software supply chain security and software bill of materials. So, of course, the obligatory welcome slide. Okay, so what is an SBOM? An SBOM, wow, it's funny. Okay, cool. Yes, okay, thanks, Neil. What is an SBOM? An SBOM is basically a list of ingredients for your software. Similar to a recipe for something you would cook in your kitchen. So basically, SBOM is the ingredient list, and your build system is the kitchen in which you assemble all these lovely parts into functional software. So why are SBOMs important? If anyone followed all the log4j, log4shell stuff, basically having SBOMs helps you identify what specific software components you have in your builds and in your software and where exactly they are. So if there's a large scale vulnerability that is found and you need to look in a lot of different places to figure out where it is in order to be able to remediate, basically SBOMs make that possible. We'll talk a little bit more about how that happens. One very important thing that everyone needs to know about is in the United States, so the president issued an executive order on improving the nation's cybersecurity, and part of that executive order was that any federal agency which is using any piece of software, not just open source software, needs to provide an SBOM for that piece of software to the National Institutes of Standards and Technology. And there's a little bit of a blurb on there, but basically they want to be able to find security risks and remediate them as quickly as possible anywhere in federal infrastructure. And so especially we've been working with different federal agencies and stuff, and so this has come up as something that's a requirement. So I'm glad to announce Alma Linux is the first distribution to notarize and provide SBOM for all of our sources and components. We actually notarize the CentOS sources as well. So that's kind of a cool like side effect of this, but part of why we wanted to present the work on this here. Why did we do this? Well, primarily, obviously, we're bored and we have nothing better to do. Second thing is security matters. The third thing is Code Notary are one of our platinum sponsors, platinum members of our foundation, and they actually have a really, really cool supply chain security suite. It's not just one thing, but they have like a bunch of different components that are part of their product. And it's really, really cool. A lot of that stuff is also open source. They have a community service, which I'll talk about in a second. But also, we wanted to bring value to obviously Alma Linux and the EL ecosystem at large, right? So the supply chain traceability of the artifacts involved in making the OS, and also this serves an additional layer of system integrity verification. So Code Notary has a couple of different pieces. The first kind of piece, and I'm going to start at the bottom, is something called ImmuDB. So ImmuDB is an immutable database. It's basically like a blockchain, but without all the bullshit of a blockchain. And there are ways to verify that the data within the database hasn't changed. This is, of course, very important for an SBOM, because once you store an SBOM somewhere, you need to make sure that that SBOM wasn't changed by someone that compromised the system. So everything in the back end is stored in their ImmuDB. Now, what they did is they have an enterprise product, which they sell, but they also have something called the Community Attestation Service. And the Community Attestation Service is basically like an open source community service, which obviously doesn't have the full feature set of the enterprise product, but it'll let you notarize stuff. You get an API key, and then you can use their tools to notarize all of your software and build your SBOMs and store them in ImmuDB in the back end. So really, really cool, cutting edge technology. This is still like, all of this stuff is really in the early days. So it's really cool to kind of like catch and ride this wave right at the beginning. So a little bit about our tools, and I want to give Javi is one of our build system developers, and so he's been doing a lot of the work around this stuff. So I want to give him a chance to speak. But basically, the tool set that we're using the CAS utility. We put together a Python wrapper just to make it a little bit easier to integrate into our workflow. And of course, our build system, and we wrote an SBOM generation utility. So I'll hand it over to Javi, who will take us over some of the like technical deep dive stuff on how we're doing this, because he's been doing the work. So I feel like he's the one that should be talking about it.
Okay. Thanks, Jack. Okay, hi guys. Okay, so I don't want to get you bored with very deep tech stuff, but yeah, so everything begins at the point where we import our, CentOS Git sources. So this way we ensure that both upstream and downstream Git sources are notarized, and we added metadata that provides relevant information about every commit. So, and we follow this process. Let's say that we take the CentOS commit. So we have the Git updater. I'm not sure. Yeah, it's a service that we use to automatically get sources from CentOS. So we take them, we notarize them, and then we create a commit into our Git repos, into Alma Linux Git repos, and yeah, we notarize it again, and then we push it, notarized. So this way we ensure that so we can keep track of the chain of these commits, and every record is stored in the CAS ImmuDB, immutable database. So this is how a source, an Alma Linux source CAS record looks like. So here we have to first explain that we have three kinds of Git sources. One is Alma Linux sources. These are sources that for packages that, for example, we have to manually update from CentOS, or that we use for our own packages, such as, I don't know, Alma Linux backgrounds or something like that. So as you can see, we have like information about the author that made the commit hash, the committer, the message, PGP signature, which is missing here, not sure why, the parent commit, and the tree. And then the signer ID, in this case, this is our Alma Linux signing ID, whether this API key is revoked, and whether this record is trusted. So if for whatever reason we want to untrust this, we just can't do it. And a user knows that this record is not, let's say, reliable anymore. So yeah. Then we have the CentOS source CAS record. In this case, it's very similar to the previous one. I mean, nothing very special about it. But when we take this record and import it into our sources, we then reference it here in the upstream commit SBOM hash. So that's, and the rest of the information is just the same. Then when all our Git sources are notarized, then we, within the build system, we authenticate every single source that has been used as an input for a build in our build system. Then we, of course, we provide some information in the user interface, in the build system interface, that, you know, that indicates you whether a source has been notarized or not. And we, when sending this build information to different build nodes, we ensure that every artifact, we understand by an artifact a build log, for example, or the output RPM package that is notarized. And yeah, and after all, we ensure that all artifacts that we are updating into our pulp instance are notarized. This is how a record, a CAS record, looks for an RPM. And as you can see, we reference the commit hash, the version of the package, the epoch, missed that one, the Alma commit SBOM hash, the architecture, the build ID, release, I mean, everything that describes a package in a way that you cannot, you know, that, yeah, exactly, that you cannot, you know, say this is another, no, it's univocally this package, this version. And that's regarding building the packages. And then there is the last process to put this into our build system repo. So we authenticate every single artifact when every package is going to be signed. We notarize them, and then again we ensure that everything that we have notarized is going to be uploaded into our pulp instance of the build system. And then there is the last leg of this thing. So we take every artifact that is going to be released into our production repos, and if it's not notarized, So we are not going to be allowed to release this into our production repos. This way we ensure that our operating system is not including anything that has not gone through the whole process of notarization. And I think that's all regarding the CAS side of things and the build system. And now we have the other part of this process, which is the SBOM per se. So we created a small utility that allows us to create SBOM documents of the builds and the packages that we released into our production repos. And we take information both from the CAS database and from the build system. And then we take this information and put together into Cyclone DX SBOM documents, and it can be either output to JSON or XML files. Then we also use this tool to notarize the Git sources that aren't automatically notarized. So, for example, as I mentioned earlier, the Alma Linux background. So this is something that we maintain ourselves and that we have to manually notarize. And we created this tool to make this process easy. And I think that's all in terms of this. So just to, I don't want to deep dive into, all the SBOM format, but in this case, I'm just going to do a quick overview of it. So we have common data in every SBOM record, SBOM document. So the format, the spec version, the version itself, because you can update your SBOM documents for a piece of software. The serial number, which is unique, a metadata block, which I'm going to explain here, and the dependencies block. So in the metadata block, this is where you put everything that is going to describe your component in a way that you add a timestamp, the tools that have been used to create your piece of software, and then the component itself, describe the component itself. This is the type of component, a BOM reference, which is unique as well, the name and the properties, okay? Then we have another blocks that are included there, such as dependencies, which is something that you have to add. This describes the dependencies that are part of your component, and then if you have another components that you are including into your SBOM document, you are going to understand this later. So this is optional. So yeah, this is mostly the common format. So for a package, we include in a component, to describe the component, we include the publisher. In our case, we just use Alma Linux. The name of the package, version, a SHA-256, the CPE, this is the common platform enumeration dictionary that you can use to identify, for example, in OVAL, we use it to describe the version of the distribution, the Perl, which is the package URL. This is a format that aims to standardize how we describe software dependencies, either coming from an RPM repo, NPM, Ruby gems, or whatever, or Python dependencies. And then a bunch of properties that are very specific to the component that you are describing here. In our case, we include the build system build ID, build URL, the author, and the host that has built this thing. And then we include, of course, the CAS hash, timestamp, package type, whether it's an RPM or a source RPM, target architecture, source RPM, epoch, release, version, etc. And then when we create an SBOM document of a build. So it's we don't include that much information, but into the components block that I referred here, the previous slide. So we add every package that has been created for this from this build, and I think that that describes every build describes very well all the components, and everything is, we keep a trace of where this package is coming from. So yeah. And other than that, so we are thinking about using this to create more scenarios where SBOM documents can be useful for us, such as, for example, adding advisory references or add a process to authenticate and verify our images and so on. And also we want to add support to create SBOM documents with another format, which is very popular as well, which is the SPDX one. And I think that's all. That's it. Yeah. Back to you.
So this is still all like some pretty cutting edge stuff. So there may be a lot of concepts that are not well understood, but basically the gist of it is that it allows us to sign everything all the way from the sources, all the way down into the release. And then this way we know every component of every package within the whole release. And then we can also revoke trust in one of those things. So if, let's say, we know there's a compromised package, we can revoke trust in that, and then that package will not be built in the build system, or anything that relies against it won't be built until we update it with hopefully, remediated package. So this is really, really amazing stuff. It's still, like I said, really, really early stages, but the great part of it is the ecosystem around this is like growing so rapidly, and there are many tools coming out which let you like automate lots of this scanning stuff. And the hope is, by jumping ahead of this and being ahead of the curve, we'll be able to integrate with lots of those tools, and we'll also provide a model for other distributions to follow in terms of what they notarize and what they release for SBOMs and stuff like that. So we hope this was valuable. Thanks for listening. If anyone has any questions, then feel free to go ahead. Otherwise, you can contact us either here in person or online. You know where to find us. Thank you.
Falcon.
Yeah.
Thank you. It's an interesting presentation. I guess that for 99% of the user, they will probably not have a look at this, because this is clearly just to be used for some kind of certification, I guess.
Yeah.
Is that mandatory to have such kind of certification to enter some markets for subscription, I guess?
So the at least in terms of the U.S. government, and probably soon the European Union, they're requiring any federal agencies that are using any software to have an SBOM for that software registered. And then I'm assuming they'll have some tool chain against which you'll be able to like do scans and stuff, automated, to be able to find all these components. So yeah, I do believe that they're also working on like a separate federal certification around SBOM as well, but that's still like really, really early on. But yeah, so there is a lot of stuff in that space around it, and there's more coming. Like I said, this stuff is like really, really early stages. So.
Hello. Hi there. This is really, really interesting. I mean, I think a lot of security vulnerability management is going to move to this stuff. There's a whole dev
Yeah.
room at FOSDEM on Sunday. Have you thought about in your system, firstly, can you integrate it with something like reproducible builds to validate in the future whether there's a build system compromise? And the other thing I'm very interested in is, have you thought about hashes get deprecated? So I noticed Git still uses SHA-1. At some point, we're going to have to migrate away from that. Have you given any thought to future compatibility more generally in your formats for future crypto changes?
Yeah, you want?
Go ahead.
No, go ahead. So use this one.
Sorry, first question was about, sorry? Can you?
I'm sorry.
Yeah. Reproducible builds. So
Reproducible builds. Yeah, that's a tricky thing to answer. Maybe Andrew, you want to talk about this? Andrew is the release engineer of Alma Linux. So can you?
Oh, it's going up.
Hi. It's pretty hard to talk about reproducible builds. Of course, if we're talking about RPM format, because it has some dates included. So if you want your like fully reproducible builds where your package will have the same checksum, it's almost impossible at the moment. So you can reproduce build chroot, for example, the same dependencies. Yes, we can do this, but still we will have different results. So I don't know if it's okay.
just repeat the second question again. Sorry. You don't need the mic. I mean, we can.
Yeah, it's all on the stream already. Go ahead.
Yep.
Yell it.
What happens when the hash changes, when we get rid of SHA-1, when we get rid of SHA-2 first days? How are you going to stay future compatible? If you archive these for 10 years and we deprecate SHA-2 first days, how do we keep trusting the S-bonds?
But why should hash be changed? Didn't get.
Hashes get deprecated over time. It's just
Okay, I see. Probably we should think about this.
Get it right at this stage.
Yep.
Yeah. It's cool. Thank you.
Sure.
Okay, and I didn't see any questions in the online
There's
chat.
another-
So,
Sean, there's another question.
oh, there's another question. Sorry. All right.
I maybe misunderstood a lot, but I just when you were describing what the content of this SBOM stuff is, it feels like it overlaps a lot with what RPM puts as a metadata when it builds a package already, like the Git sources, verification, build information, and everything. Is it like but you still collect this SBOM data from the Git sources from the beginning, but wouldn't it make sense to use RPM metadata as a source for this? Or like, do you do a cross check between SBOM metadata and RPM metadata of binary builds you get? So how these two different information pieces are working together?
I mean, I don't have a a good answer for this, but so we trust we trust our chain of traces. So we imported Git this, and we are indeed using the RPM specs data that it's already there. So somehow it's included. So I'm not sure whether I'm asking your question. So yeah.
Yeah, I think she just means instead of us pulling it, like grabbing it from the RPM metadata to put it into the
So it's
SBOM spec.
so it's
what we do.
We do that already. Yes, we're taking the data
Yeah.
from there.
Right.
It's not something that we're making up or from. No, it's just there. Yeah.
Great. Okay. Let's wrap up and move on. Oh, there is a question in the chat. Oh, excuse me. We missed an online question for the last talk, so I'm going to try not to here. Wonder if SBOM criteria has vulnerability links as part of notification systems to trigger upstream packages, RSS feed, direct, etc., or do they rely on current methods to get and check vulnerabilities?
So if the question is, do we do any notification of upstream if there's any like vulnerability or anything? No, not yet. We don't have that piece figured out yet. But the plan would hopefully be to collaborate with stream maintainers and rel maintainers to make sure that anything that's that's found anywhere is obviously remediated and someone gets notified somehow. So, but again, this is like the early stages of this work, so it's still too early to kind of be there yet. But we hope that's what the plan is, and that's kind of the value we saw in embarking on this project, is that something that will add value to the ecosystem as a whole, not just for our distribution. So
Great. Then thank you, all three of you, and we'll move on to the next talk. Thanks.
thank you.
So next, we should have Peter Georg doing the KMod SIG up. Oh, there you are. Right. Okay. Yes.
Okay, I think that looks good, and I hope everyone can hear me. Okay, great. So let's just start. Okay, today I'm representing the CentOS KMod SIG. So my name is Peter, and I also put my affiliation there. So it's just there because everyone has this fancy company logo. I don't have a company. I'm working in academia. And to emphasize that, because I'm working in the public service for the state of Bavaria, there's no commercial interest at all. Whatever I'm saying, no commercial interest, and it's my personal statement. Whatever I'm saying, my personal statement. Yeah, probably not the first time you have heard that. Okay, first a few overview. The beginning, so the KMod SIG was established in June 2021, so it's not that old yet. Here, two important links. So the first one, if you're interested in what we are doing, the documentation link is where you should go. If you want to see more technical details, you go on GitLab. So everything we are using nowadays is there. It's one single source, all is in that group. Okay, so what was the KMod SIG about? Well, what is it about? We want to provide kernel modules that are not included in CentOS Stream, and then of course not in Red Hat, not in Alma, not in Rocky. Okay, here are some lists. So we have some kernel modules which are restricted in support, because Red Hat at some point decides, okay, some devices, we do not support them anymore. So they have these fancy if-def-rel differences, and they just mark some PCI IDs as not supported anymore. Okay, we remove these if-defs. That's it. Okay, then we have in-tree kernel modules that are simply not enabled because no one wants to support them. So we just say, okay, we might support them as a community, so we add them back again. We might also backport new in-tree kernel drivers, kernel modules. I think one example is the NTFS kernel module is now in, I think we provided for both 8 and 9. That's an example there, and also out of tree kernel modules, but there we are limited to GPL only. And I think currently we have no example for that group because everything that was out of tree is nowadays in tree. Okay. And of course, some of these modules require user space tools, so we also provide these. There was some discussion if these should be in EPEL or we should provide them. And the agreement at the end was more like it's better to have them with the KMod SIG instead of in EPEL, because in EPEL, if you just apply it to Red Hat only or any other, it makes no sense. You cannot use them. Okay, good. So what we have nowadays, so we have these KIBI tracking kernel modules that are ready to go. You can install them easily. And here I marked one thing which in my opinion is important, especially as we are mainly targeting stream. So because there are also other sources for some of these K-mods. But what's a difference is that we do actually allow you to install multiple versions of the same K-mod in parallel, which is great if you're working on a stream machine like my laptop, because some stream kernels probably just don't work. So I want to switch my kernel, but want all my K-mods to still load. So that's what for me was important. Okay, then we have a second one, which is, yeah, it's not checked yet. We at some point want to sign these kernel modules, which is important for secure boot, but there we are waiting for, yeah. There's a link, you can look it up, it just takes time. Someday, yeah. Okay, then the accompanying user space tools, these are done as well. There's everything fine. Then driver disks, that was, I have no personal use there, but some people requested that, and thanks to the infra, we got that for free. So we actually did nothing there. I did nothing, we get them for free, so great thanks there. And we, at some point, because at first we only wanted to support stream, at some point we realized, okay, if we support stream, it's easy to support anything that's downstream of CentOS stream, like Red Hat, Alma, and Rocky, so we just added these as well. But there's also a small part that's missing. I think Neil asked about that a few days ago, so we don't have any easy way yet to install the CentOS release K-mods package on Red Hat Enterprise Linux. That's also, again, you can look it up why, it just takes time. Okay, but working on that. So you can also easily install it on any other distribution. Okay. So that was the overview. Now it's getting a little more technical. To first motivate that, okay, so the KABI is something important. We already heard in the first talk today about that the ABI is stable for Red Hat, for RHEL, but not the KABI. The KABI, there are some symbols, and now we have a difference between 8 and 9. In 8, some symbols were marked as stable for the major release. In 9, it has been changed. Now it's only stable for minor release. But important is to note that this has only been about a subset of the symbols anyway. So you really need to find a kernel module that only depended on these symbols. And to be honest, I never found one. None of the modules I use was able to be compiled only using symbols on the stable list. But still, that changes something. So I looked up some statistics because we have some fancy online plots where we see how often we have to rebuild our kernel modules. So it seems like it changed still. It changed something for us. Because with CentOS Stream 8, there's only a 55% chance that we need to rebuild a module. In 9, it's 92. So that's bad. Especially as with CentOS Stream 8, at least now, I think there's some changes in the background. The stream kernel releases are quite irregular. So I think there was one in the last 4 months. And with Stream 9, we get like one every week out to the mirrors. So that's a lot. So and if I have to do have to rebuild every kernel module every week manually, I'm not going to do that. So that's obvious. I'm not going to do that. So the only way forward is we need to automatically do these rebuilds. Because usually most of the time it just means I need to grab my sources again, change the kernel version I build against, redo everything, and that's it. So I don't need actually any manual steps most of the time. Okay, here overview how we do that. So in the beginning, we worked with the OpenShift CI that's provided, but then once we were allowed to move to GitLab, we did that because I want to have everything in public. I want that everyone can just look up what we do there and even see what is running. So you can go there, you can see exactly how we do that. There's all this, I have nothing on my laptop. It's all on GitLab. Okay. And, well, I'm a software developer, so I'm used to GitLab. It's the other simple reason. I know that tool chain, it's easy for me to use it. So it was the most straightforward way to set it up. Okay. Here mentioned that we use actually different Git branches for each kernel version. That's important because if I want to update a K-mod built for a certain kernel, it's getting complicated if I already move to a new one. So So I really have one branch for each kernel version, and I can easily make changes there. Then the CI triggers again and builds it for the old one. So if, for example, if I find a bug in some kernel module, I can say, okay, I apply it to the last 5 kernels that have been released, and that's just cherry picking the same commit for all 5 branches, 5 times push, the CI will take over, I'm done. That's nice. Okay. And because that also happens from time to time, I think in Stream 8 it happened twice last year, and it actually happened once this year in RHEL. Sometimes, because in this, to have these KIBI symbols that on the stable list stable, there's a lot of stuff going on in the source code, and sometimes it leads to that some symbols are claimed to be stable, but they're actually not, which is obviously a bug. But what should you do? Of course, there's a new kernel, so it might be that we have to manually do rebuilds because our system will not see that, because the symbol claims to be stable, but it is not. So I have to do manual rebuilds, so I just add a new branch, push the branch, I'm done. Okay, and apart from that, we are heavily relying on Git tags, but that's mostly to track the progress of the system, because I often need to download like the kernel sources and other stuff, and I don't want to do that again. So I do it once, and I just push a tag to mark like, okay, I have already looked at that kernel, I'm done. So the next time the CI is triggered, it just sees like, oh yeah, I'm already done, I just skip it. So even if nothing changed. So it might be that in some Git repositories, you see one commit, and there are like 25 tags for that one commit. Which usually makes no sense, but I'm using it to track my progress there for the system to be more efficient, because we don't want to, okay. For all that to work, we have one central repository which is tracking the KIBI info. So essentially, there are all these module.symverse.architecture. These files are in there for every kernel that has ever been released for Stream 8 or Stream 9. So that might even be interesting for some other people if you want to check out if your kernel module works for some specific kernel. You can check it against that repository to easily. They're all in there. And of course, the creation of this repository is also automated. So I'm also not doing there anything anymore. I just wrote the script once to do it, and we are done. Okay. So that's the overview. Now with automation, there have to be some flowcharts. So that's how it works, actually. So that's more the technical part now. So now you have a nice overview, now the technical part. So, and here at the top, you see like that's how we build from dist git. So we have 2 different kinds. We have some packages we use dist-git and some we use source-git. I think most people know the difference. Okay, so for the dist-git case, I have my start. I check if my sources, which are in the looker side cache, are actually on git centos.org, because otherwise I cannot build. And if they're not there, what I do next is I check the Fedora looker side cache. No, why should I do that? That turned out to be quite useful for the user space tools, because most user space tools are actually maintained in Fedora, and now maintainers can just cherry pick commits from Fedora to the kmod SIG, and the sources will be copied from Fedora, looker side cache to the CentOS one. So again, one step less that I have to manually do on my laptop, because most people don't have access to the CentOS looker side cache. Okay. Okay, then we look, have we already built it? If not, okay, we first do a scratch build to see is it actually working. If the scratch build succeeded, then we do the real build, we do the tag for the testing, and then the tag for release. So and I only here have 2 steps only that might require manual steps. So either the sources are missing, then I really manually have to do the looker side upload and so on, or my scratch build is not working anymore. Which means probably there have been some changes in the kernel which require source code changes in the module. Happens. Okay, so these are the only 2 cases. Otherwise, I don't have to do anything. Just a note, because we are also using this for the user space tools, which I think is quite nice, that we can use the same. And what we are currently not using, but what might be useful for other SIGs, is that at the end, and that's why I separated the tag build for testing and tag build for release, you can actually mark the last step, the tag for release, you can mark it in GitLab that it requires a manual interaction. So then you can do your testing, and once you're done, just open the GitLab, you go in the pipeline, you say like, yeah, I'm done, you click on OK, and then it's running the last step. Sure. Okay. So for source Git, it's even easier. So we first create an SRPM, really classical, try the scratch build. If it's not working, I have to fix it. If it's working, if it's a new version, if it's working and a new version, I push the new dist-git, and then it triggers this pipeline again, but of course without the scratch build in CBS, because that one we already did. So we don't want to stress CBS too much. So we try to be nice. Okay. That part, okay. So, but now that's more the more interesting part, because now this was just how to build my kernel module, my package. But I also want to track when do I need to rebuild it. So that's a different pipeline. Here for the dist-git. So at the start, at the beginning, I check for which kernel the latest version has been built. I get that kernel version. Next step, I check, are there any newer kernel versions available? If not, I'm done. So that script really, the pipeline, if it's a no, it takes 5 seconds. It's done. If there is a new kernel, now we have this loop, I check, are there any new symbols? Have any of the symbols I am dependent on changed? If no, I go back, are there even more new kernels? If not, we are done again. But if anything changed, I bump the spec file, I update it. That's essentially just it's 1 or 2 SED commands, that's it. And I push the new branch to dist-git. And then the other pipeline triggers again. Okay. Now the most complicated, and then I stop worrying you. So the source Git one. Here at the beginning, we have the part where I actually check for new sources available. And there I actually had some discussion with some people from Red Hat that said like, that's not a good idea. Some others said that might be a good idea. At the end, I decided to go, or we decided to go that way. So what I mean with new sources available. So most of the kernel module sources are in-tree and are part of the CentOS Stream kernel sources, but not officially maintained by anyone at Red Hat. So Red Hat, they are allowed to break these modules. They can do some backports, not caring about these modules. They might be broken. That's fine. But most of the time for the maintainers, it's actually easier to simply cherry pick one of the commits from the upstream kernel and apply the changes to the whole subsystem at least. So if there's a subsystem change in the kernel, also the modules that are not compiled for CentOS Stream get these changes. So I want these changes as well. So that's why in this first step, I actually extract the source for the kernel module from the CentOS Stream upstream, from the CentOS Stream kernel. Turned out quite well. Most of the time it really works. So I extract these sources. If there are any changes, if they're not, I just keep the old ones. Okay. And then it's again actually, yeah, at the end it's a little bit. So then like with the dist-git, I get the current version. I check if there's a new kernel available. If yes, I check have the sources been changed. If the sources have been changed, I'm 100% certain I have to rebuild. Because if someone touched the sources, I should do a rebuild. Okay. If not, I check the symbols. Have these changed? So it's just one logic more than before, but that's it. And at the end, of course, if the sources have changed, I have to do a git rebase. I rebase on the new sources. If they have not changed, I just do the bump spec. And the rebase might actually fail. And I think in the last two months, the only manual step I had to do for all the kernel modules provided by the KMod SIG has been due to that. So I think what was it? Yeah, there was some new if-def rel difference was introduced, and my patch did not apply anymore. So I was like changing 2 lines in my patch, and that's it. So that was also easy. Okay, so apart from that one time, everything we release, and usually that's once a week, like in total, I think it's by now 8, and for 9, it's maybe 30 to 40 K-mods. I only had to spend 5 minutes in the last 2 months to provide all these. So that's really nice. So it seems like the system is working. Okay, and apart from that, we're already done, because I think we already laid a little bit anyway. So any questions, please?
Let me check the on. Yes? Okay.
Are the kernel modules for proprietary devices considered in the scope of KModSig? And if it is done so, how does the build system look like? Because it can't be done by a virtual machine, a generic virtual machine of some kind.
Sorry, I didn't get the first part.
Are the kernel modules for proprietary devices considered in the scope of KModSig? Proprietary devices, the kernel modules for them?
For prop?
Well, take for instance, there are audio drivers, they have pertain to a certain card. So are these considered like that, or is it not?
Sorry, I just didn't get your question.
There are proprietary devices that require a certain level of kernel modules to be installed for them to work. So are these considered inside the scope of KModSig?
So yeah. Our limitation is GPL only.
Oh, GPL only.
GPL only. In tree, which means GPL only. Out of tree, also GPL only. So if you're thinking about NVIDIA, the old kernel is leased, the old kernel module, no. We were told that if we want to provide these, we have to talk with Red Hat Legal.
Right.
And I tried to avoid that part.
Fair enough. No, in order to build certain kernel modules, even when they're GPL only, they require the presence of those modules to be there in that build environment.
Yeah, but then someone needs to provide these, and we can't.
Exactly.
Yeah, and we can't. And these cannot be available in CBS, because everything that's in CBS has to be built in CBS.
Exactly.
And you're not allowed to build there anything that is not GPL, at least for the kernel, or otherwise probably as well, or some other license allowed. So no, anything that depends in the kernel on a non-GPL kernel module or itself is a non-GPL kernel module is, at least for what we do currently, out of scope. And we just hope that most hardware, they will realize that going GPL and going in tree especially is helpful for everyone. And we actually thought about packaging the new NVIDIA GPU kernel module, which is GPL.
Yeah.
We thought about that, but I tried it on one of the machines I have access to, and I was not happy with it at all yet. So I'm waiting a little bit more for it to get stable, because I don't think there's much use of it yet.
Yeah, circling back to the test that you did on your machine, so it requires a certain kind of hardware for that to be tested, right? So how exactly do you automate all these things if
you want to test it, now, these tests I cannot automate.
Exactly.
These I cannot. No.
So it needs to be done voluntarily on devices.
Currently, what we do in our system, the tests are simply, does it compile? So anything else, we have to plug in something else, because of course all these kernel modules probably depend on some hardware. Yeah. So testing is an issue. Yeah.
Understood.
Yeah.
Thanks.
Are there any more questions? Okay, then we'll move right on to another. Oh, thank you for the presentation. And we'll move right into another SIG update. And Davida will talk about the work in the hyperscale SIG.
Okay, let's see how this works. You have HDMI. Yeah, we'll find out. You never know. Maybe it is the year of the Linux desktop. Is this my mic? Yeah. Okay, so I don't need to use the thing. Okay. Is this? No, this is not working. Displays, mirror, apply, keep changes, much better. Slideshow. Okay, does the clicker work? Excellent. Okay, see. Can you hear me from here? Do you need to be closer? Okay, sorry, I tend to move a bit. Where's Sean? Are we good? Cool. Hi, everyone. I'm Davide. I co-chair the Hyperscale SIG with Neil, and this is our update on latest activity. We'll go over a recap of what the SIG does and what is our work. We'll talk about deliverables and the recent activities, the recent updates, and finally we'll close with a few words on what's coming up next. So the Hyperscale SIG is primarily focused on CentOS Stream. The idea is to have a place for companies and engineers that do work on CentOS Stream deployments at large scale, so that we can join forces and try to do all of this work upstream instead of everyone doing it within their own environments and then never seeing the light of day. So we want to foster collaboration both on packaging work, but also on tooling and processes, and trying to generally make CentOS easier to use and consume for these kind of deployments. While a number of large companies are members of the SIG is by no means exclusive to large companies. If you're interested in doing work in this space, you're more than welcome to join, and we're always looking for more people to contribute and help. We were established in January 2021 with 6 members. I'm quite happy to see that the SIG has been steadily growing over the last couple of years. We're now at 29 members. It's been really, really nice to see this community blossoming, seeing people focus on their areas of interest and developing it further. We hang out on IRC in CentOS Hyperscale, which is also based on Matrix. Most of us are in the US, so we'll be around on US time. In Europe, if you're right there in Europe, it might take a while to get a response. We have bi-weekly meetings that are recorded, and you can find the minutes there, except I think I forgot to update that page for a while, so you might be missing the last 2 or 3. We also do monthly hackathons and video hangouts, which is something that we found really useful to foster social interaction between folks. These are usually a mix of people doing actual works and general just chit-chat and spending time. And finally, we started doing in-person meetups. Now we can go to conferences again. We had a meetup at Boston last year during DevConf US, and we just had one yesterday here, co-located with Connect and FOSDEM. These are a lot of fun, and it's a day where we can spend time face-to-face, work through problems, and discuss what we want to do in the future. If you're interested we'll definitely try to do more of these in the future, so I'd encourage you to attend. You can find our charter on the CentOS Wiki. We also have a documentation website on sig.centos.org. That's where we keep all of our user documentation around the SIG, both for how you can consume our content, but also how people can contribute. We also post activity reports on the blog, which are all linked there. And we also give conference talks. So our recap our talks are also on that page, so I don't have to link them here. We use Pagure to track ongoing work. So we have issues on that issue tracker. So if you want to get a sense of what we're working on right now, you can skim that. So what do we actually do? The main thing that SIG provides is faster moving package backports. So backports of packages that are available in CentOS already, but we would like to be able to track a more recent version, maybe because we do active development, or maybe because there are more features that we want to make available. And these are meant to be drop-in replacement. The other set of things we carry are packages with policy and configuration alternatives. So packages that are slightly different from the ones carried in CentOS in terms of options of what's enabled or not. So for example, say an IP tables package that also has the legacy backend enabled. Then the other category of work we have is dedicated repos to track large-scale testing for ongoing work. So for example, we have ongoing work around RPM and DNF, and this is not the kind of thing that you probably want to deploy in a production system, but it is very useful to have in a state that is deployable, so you can try it out and use it. Also as a byproduct, because we do use this stuff at Meta, it makes it very easy for us to deploy it internally in the same way that it's published outside. We also do work on the kernel, and I'll talk to that in a little bit. And finally, we publish live DVD ISO images for a distribution spin. So let's start with packages. Packages are deployed in the Hyperscale main repo, which you can install by installing our release package up there. As I said, these are meant as drop-in replacements, so they should behave the same as the stock CentOS packages, except providing extra features or being a more recent version, and so on. If you find bugs on them, please file bugs on our tracker and not on Bugzilla, because otherwise the maintainer of the package in RHEL and CentOS would be very confused, because this won't be their package, but our package. We have EPEL as a hard requirement, well, partly because EPEL is really useful, and there's very few instances where you would want to run CentOS without EPEL, but also because EPEL provides a lot of packages that we have as build dependencies, so it makes our life a lot easier being able to rely on the work that's happening in EPEL. And actually, most of the time, if there are packages we need that are eligible for inclusion in EPEL, we'll prioritize getting them in EPEL rather than branching them for the SIG, because then they can be useful for everyone, also for people using the rebuilds, RL proper. We build packages for x86, 64, and AR64, because those are the platforms that we can test and apply on. If someone's interested in adding support for PowerPC or S390, be my guest. We would love someone to come and do that, but we have no ability to test on those platforms. We have a lot of packages in the SIG, and you can see the tags. I put the link to CBS there if you're curious. The latest things we added were a number of shells for developer workstations, updates to iPerf3, a backport of DMI decode for improved hardware support for modern platforms, a backport of dwarfs for CentOS 7, for PAHO specifically, a backport of Wireshark, which added support for more protocol dissectors, an updated version of the FIO benchmarking tool, which also added support. These are mostly hardware enablement stuff now that I notice here. And finally, a number of folks at Meta that work on time and timing infrastructure started working on maintaining an updated version of Linux BTP within the SIG based on the internal one we had. And this is a work in progress. This is ideally something that will completely disappear in the future as this gets upstreamed into Linux BTP proper. But in the meantime, we are maintaining it in the SIG, and everybody else can use it if they want. There's also work in progress around OpenSSH and QEMU. For OpenSSH, this is something that's being driven again by Meta, because we have an extensive patch set around OpenSSH that we're slowly trying to upstream. So we're using, this is a bit different from how we normally do things. We're using the SIG as kind of a staging area for this, but we're not publishing package builds for this because we don't believe they're in a state where they will be useful for the community. But the sources are on GitHub. So if you on GitHub, on git.centos.org, obviously, not on GitHub. So if you are interested, you can look there. And at some point, I expect the patch set will shrink to a manageable size, and then we will be able to publish versions of this. QEMU is the same, slightly similar story. We would like to get QEMU branch for EPEL. There's a lot of challenges in doing that, so we're attempting to use the SIG as kind of a staging area for this. Again, none of these are in the actual release repository right now, because we want only stable stuff to be there. One fairly recent development, well, from last year, I'd say, is that we have automation now to track package updates. If you run a SIG, you will know that you have to make sure that your packages are higher versions than the one in CentOS. Otherwise, they can get shadow when there's a new build that happens in the distribution. We have automation that leverages the MQTT notification that are provided by the project, so that whenever there's an update upstream, we get an issue file in our tracker, and then we can go ahead and update our package in time so that there is no disruption for users. This is still somewhat manual because a human needs to go there and actually make the update. I'd like at some point to have automation for these. Not necessarily automation to build and publish it, because that's kind of risky, but at least automation for kind of like release monitoring works in Fedora. So something that would tell you, this works, this builds, here's the diff, and then you can just apply the diff, build it, and if it works, it works. That's something for in the future, maybe. Someone's interested in working on this, by the way, feel free to talk to me afterwards. One of the main packages that we have in this repository is systemd. We branch systemd and try to track the latest systemd upstream version. Right now we have 250. We have builds of 251, but didn't tag them in the repo because we weren't satisfied with the amount of testing we've done for them. Dan, who's sitting right there, is working on 252 right now, and that should be coming up soon. These are built for CentOS 8 and CentOS 9. Because they are upstream systemd builds, they have slightly different defaults from the one you would find in RHEL or in CentOS proper. These default to the unified hierarchy on both 8 and 9. They also ship a plethora of additional daemons that aren't normally available. So they ship UMD, which on 8 also needs PSI enabled. They ship networkd, they ship resolved, they ship the full set of optimizations. We also backported a number of improvements to journald, which are especially useful if you happen to run on a copy on write file system like BudderFS. And because CentOS uses SE/Linux upstream, these also include a fully functioning SE/Linux module. And I say fully functioning because while we do test this and try to keep it working, as far as I know, none of us actually run SE/Linux in production, so we only have limited experience with it. So if you find bugs on it, please do let us know. I will try to fix them. Or even better, if you know how SE/Linux works, that would also be useful. You can find our repo there. That's where we track development and stage patches. We try to have a very minimal amount of patches and do all the work upstream. A number of SIG members are also upstream systemd contributors, so that makes it easy. Our Rallian scripts are also public, and you can find them there. And in general, the development process is reasonably well documented. We also used to have a CI on the CentOS CI that would do daily builds of systemd, but this is currently broken because of a number of changes that happened upstream that made it essentially fall out. We are hoping to get this fixed concurrently to 252 so we can restore it, because it was quite useful to have. And one thing we would also like to have at some point is the ability to spin up VMs so we can do end-to-end testing for these builds, because systemd is the kind of thing that you really want to build a machine to make sure it's working. Another recent addition is that SIG members from Intel started working on a number of package backports with optimizations that are specific for Intel processors. These are delivered to their own dedicated tag and repo, so they're not in the main package because they replace system packages. The one that is released and available right now is zlib, which improves major performance improvements by using SSH2. There's also an experimental glibc backport in the works. And these are meant to be API and ABI compatible, so they should be drop-in replacements. Obviously, they only work on x86-64, because, yeah. You can find the link there to the tag, and the ones for CentOS 39 are in the work. Speaking of CentOS 39, it exists. We target Stream 8 and 9 concurrently, and we've also been using the SIG as a way to funnel contributions upstream to CentOS proper as much as possible. We don't want to maintain things in hyperscale if we don't have to. So throughout the last few years, we've been able to get a number of changes into CentOS Stream proper, and that means these are things that we don't have to maintain ourselves. And that's the list which I want for your reading, but you can see later in the slides. I mentioned earlier the large-scale testing. The main example we have is the RPM copy on write work. So we have a fairly extensive patch set on top of RPM and DNF that we've been working on for the past few years that adds copy on write support, so that if you run RPM on a copy on write file system, such as BudderFS, packaging operations are a lot more efficient because they can leverage the file system features. This is in various inactive development, I would say, and we are working with the RPM maintainers to find a path to upstreaming these, or upstreaming the parts of these that have to be upstreaming RPM proper, so that this patch set can be maintained on its own. But it does work, and it is something that Meta in particular runs in production, because we find it quite useful. So we publish the whole stack, so RPM, DNF, librepo, the entire thing, into a dedicated tag and a dedicated repo. So if anybody can use it, you can get it by installing our release hyperscale repository. And I added links there if you're interested in the current development there. On the kernel front, which I mentioned, we maintain a 5.14 kernel based on CentOS Stream 9.3 for both 9 and 8. So we have a backward of the 9 kernel on 8. This is the stock 9 kernel with a few minor modifications. The main thing is that we enable BudderFS support, and we backported a number of fixes for BudderFS itself. So if you, what? And simple DRM, and Neil reminds me, thank you. So the idea is that if you boot with this kernel, you can install your system on BudderFS and use BudderFS on CentOS Stream 9 out of the box. There is one catch, which is this does not have secure boot support, which you can read that CentOS infra issue for the entire story, and I'm happy to talk to you about this over a stiff drink, but it is too long of a story to go over in this talk. If you want to try this, it is available in the same repository as mentioned before. Again, we've been leveraging this work to also contribute to the CentOS 9 kernel proper, to try and get changes contributed upstream. Right now, it's mostly being build fixes and enablement changes for other features, but in the future, we would like to find a way that we can maintain subsystems such as BudderFS directly upstream in the CentOS Stream 9 kernel, so we don't have to keep them downstream. To this end, we have a documentation specifically on how to contribute and work on the CentOS Stream 9 kernel, because we found that the process needed documentation for sure. Additionally, one thing I wanted to mention, the talk before me was the KMOS SIG. The KMOS SIG maintains the exact same code for ButterFS, but in a K mode. So if you happen to run a stock CentOS Stream 9 RL kernel, you can also use KMode ButterFS if you need ButterFS enablement. And that has been a nice example of synergy between different SIGs. So you have multiple avenues if you would like to use ButterFS available to you. On the user space front, well, again, ButterFS stuff. So we backward ButterFS progs from Fedora, we backward composites. Neil also restored ButterFS support in the installer, so you can actually install a system on ButterFS. We also have a backward of eStool with improved hardware support for modern system. I believe this was actually rebased in Stream 9 already, so we might not need this anymore. I have to double check. Finally, Meta in particular uses Kpatch extensively internally, but the version of Kpatch that shipped in CentOS doesn't include the build part, the thing that allows you to make kernel patches, which is the actually interesting part of it. So we publish backport of Kpatch, the latest version with the build part added back, and also including support for kernels built with Clang, especially using PGO optimization, which is something that we use internally, but is generally available and hopefully can provide some value if someone else wants to deploy kernel life patching in production. On the container side, we also have a container image for hyperscale. This is a built from scratch container image. It is not based on the stock CentOS container image for historical reasons. You can find the scripts that I used to build it there, but it's like what you would expect. It just uses builda and the normal flow. It's published on Quay. It used to be published manually, but this day we actually have automation for this. So there is an periodic task that runs in OpenShift that will build and publish these, I think every day or something like that, every week. Well, that's still good enough. So it should still be a fairly up-to-date image, and it's useful if you want to test something quickly. This has our repos enabled already, runs our systemd and all of that. And finally, Neil builds media spins for the distribution. So we have live DVD images that look like if you've used Fedora, you know the Fedora live DVD installer images. So it's the same flavor of image, but running CentOS. We have spins for CentOS Stream 8, 1 week Gnome and 1 week KDE Plasma. These use our kernel, our systemd, and our packages in general. And they're meant to be kind of a showcase of all of the features and tools that are provided by the SIG. Right now, we only have this for CentOS Stream 8, and the build process is somewhat manual. We are hoping to be able to automate this in the future so that we can do builds for this on CBS and also do builds for CentOS Stream 9 and release this on the Miro network rather than on a random S3 bucket that I'm using right now. But eventually this will get productionized better. In the meantime, if you do try this and find bugs, please, again, file them on our tracker. Do not file them to CentOS proper because people will be confused otherwise. Coming up, as I mentioned, we would like to be able to do live media images in CBS because that would also be useful for other folks. You might know that there's also an alt images SIG, which is trying to do this kind of work at a higher level so that multiple SIGs can leverage it. And we are working closely with them to try and make this a reality. I mentioned earlier, we're also working on getting QEMU in Appel, which is ongoing work. And finally, as kind of more aspirational things we would like to do is find a way to implement ButterFS transactional updates and deploy them for CentOS and have a set of cloud images published and available for hyperscale on a continuous basis. I will leave you with a few more links. Again, where you can find us on IRC, the calendar for our meetings, the issue tracker, and if you want to have a long-form discussion, we hang out on the CentOS mailing list. That's all I had. Happy to answer any questions. Cool. Thanks, everyone.
And then our last talk before we might still have a break, will be Adrian. He's already setting up, so great.
Hi, so welcome to my session Mirror Manager in CentOS Stream 9. Mirror Manager is a tool that's been used in Fedora for a long time to manage mirrors and get you the best mirror, hopefully. And since CentOS Stream 9, also it's responsible for getting you a CentOS Stream 9 mirror. So just a bit about myself. So I'm actually running a mirror server for a very long time at this point, and that's why I'm interested in mirrors for some reason. I'm involved in Fedora for a long time, and for Fedora US over 20 years ago, I actually also wrote a mirror managing system. It was never deployed, and it was bad, but so I'm for some reason interested in this, and I'm involved in Fedora's mirror manager since about 2008. I wrote the first patches. In around 2016, I became the main point of contact for mirror manager in Fedora and upstream. I work in the Red Hat core kernel team, mostly on checkpoint restore and containers, but mirror manager is something completely different from that. So the agenda for today is a few questions I want to answer is, what is mirror manager? So why do we deploy it in Fedora, Apple, and CentOS Stream? And who uses mirror manager? Just a couple of the users who are currently using it. And how does mirror manager work from the point of view of DNF install update? What happens? How do you get your RPMs with the help of mirror manager on your system? And then some numbers we extract from mirror manager log files. So what is mirror manager? Mirror manager is a tool which tries to find the best mirror for you. The best mirror is a mirror which is hopefully up to date, and a mirror which is close to you from the network point of view. And we do this by looking at your IP address. And based on the IP address, mirror manager tries to create a list of mirrors which are hopefully the best mirrors for you, or pretty good at least. So the first thing mirror manager does when it gets your IP, it looks at net blocks. So mirror manager, there are a couple of systems which people implemented over the years who help maintaining mirrors. And mirror manager is one of the few, I think, which have a self-service interface. So if you want to provide a mirror for Fedora, Apple, or CentOS Stream, you can create it in mirror manager in the instance from Fedora. And then you can configure a few things. And one of the things you can configure is you can say, I'm responsible for those net blocks. So my mirror is in this network, and the networks around it are also really close and probably have a good connection to my mirror. So mirror manager will look, is there a mirror in one of the net blocks close to you? And if it is, it will put this mirror on the top of the list of good mirrors. Then the next thing a mirror manager does is it knows about private mirrors. So a private mirror is a mirror which is maybe behind a firewall, but a private mirror is a mirror where you do not want, or where the mirror administrator doesn't want anyone from outside of the organization that people use that mirror. So you can mark your mirror as private, and if you're a university or a company and the mirror is behind a firewall, then your local users will be directed to this private mirror, but nobody else. Special thing about private mirrors is that we do not check private mirrors to see if they're up to date, because the assumption from our side is we probably cannot reach it. So it's up to the maintainer of the private mirror to ensure that it's up to date, and mirror manager will believe that it's up to date. So once we looked at net blocks and private mirrors, we will look at the ASN, the autonomous system number from your network, and we will look, is there a mirror in the same ASN? Is there a mirror maybe in one of the neighboring ASNs? So if it is, then we will give you also some mirrors from those ASNs. Then what we still do is Internet 2. So Internet 2 used to be, or maybe still is, the research network in North America. In Europe, it's called GÉANT. And they used to publish routing routing tables. So we could figure out, is your IP part of Internet 2 or not? But this has stopped. So the plan is to stop suggesting a mirror based on Internet 2 routing tables. So currently this is still working. We're using old routing tables, but this will disappear soon. So once we have done those steps, NetBlock, ASN, Internet 2, then we will look at the country your IP address is based in, and then we will add mirrors in the same country. We will add mirrors in the same continent to the list of best mirrors for you. And then the last step is we might add global mirrors. So global mirrors are the primary mirror, or the CentOS Stream has a CloudFront cache. And if the number of mirrors in the previous step is below 5, then you will get the global mirrors also as a result. And the idea is just to give you a minimum number of mirrors where the DNF can find at least one working mirror if for some reason you get a mirror which is not up to date. Then with all this information, we randomize the net blocks and order by prefix size. For all the other cases, we do a weighted shuffle by bandwidth. So each time you ask for a mirror, you get a new answer, but we try to put high bandwidth mirrors higher on the list. So the load is distributed, but chances that you are redirected to a fast mirrors are higher than to a low bandwidth mirror, but low bandwidth mirrors are also included there. And then you get a list, and then DNF can select one of the mirrors and download the packages for you. So who uses Mirror Manager? Fedora and Apple uses it since 2007, and it was originally implemented by Matt Domsch in 2007, and the core concepts have not really changed since then. Parts have been rewritten once or twice, but it consists of the same components as in 2007. RPM Fusion uses Mirror Manager, Rocky Linux uses Mirror Manager as far as I know, and since CentOS Stream 9, also CentOS Stream 9 uses it. For CentOS Stream 9, we didn't do a new installation of the whole system, we just extended the existing configuration files to also look at CentOS Stream 9 primary and mirror and all the mirrors who are registering for it. So how does Mirror Manager work? What happens during DNF install? So for DNF's point of view, Mirror Manager has two interfaces. The one is Mirror List. This is just a simple file or simple answer with a list of mirrors. And as far as I know, Rocky Linux uses this interface. And the other one, which is used by Fedora, Apple, and CentOS Stream 9 is the Metalink interface. And the Metalink interface tries to provide a way how RPMs get verified. There's a verified way how RPMs get from the first request to your system, with each step being verified by the previous step. This only works if you trust DNS and HTTPS. But if you do, there's a kind of a chain with checksums from start to end. So this is something which DNF will use for CentOS Stream 9. This is the base repository, and it's about a Metalink it wants to download, and it's for the architecture x86-64. And then Mirror Manager will do in the background steps I've just described here before. And then you will get a list which looks something like this. And so this tells DNF it's about a file called repo.md.xml. You get a number of checksums the file should have. And in addition to the file name and the checksums, you get a list of mirrors where DNF should try to download this file from. So DNF will go to the first, actually I don't know how DNF works, but this is my assumption. It will go from top to the bottom of the list. It will download the first repo MD XML file, check the checksum against the one given in the meta link. And if it matches, then DNF will use that mirror for that transaction. In repo MD XML, if it matches the checksum, there are pointers to other files also with checksums. So DNF can go and download this additional repository metadata, verify against the checksums in repo MD XML. And if this matches, then it can download the actual RPM, install it in your system. The RPM is usually it's signed. And so from the first download of the meta link to the installation of the signed RPM, there's kind of a way how you get each step verified by the previous step. So I have some numbers about the Fedora instance of Mirror Manager combined with Apple and CentOS Stream. So currently we have in the database over 1,200 mirrors. This includes private mirrors, this includes disabled mirrors, inactive mirrors, everything. Each mirror can decide if it only wants to do Fedora or Apple or CentOS Stream. So from this number, you don't know how many mirrors each project has, but this is just the overall number. We create a map where the mirrors are located. And currently, Mirror Manager answers to about 64 million requests per day. So 64 million times per day, we get a request. I want to have a mirror list. And from these numbers, from these raw numbers, unfiltered, we create a couple of diagrams. One diagram is, this is by country, from where are all the requests coming. Then we have a diagram by repository. So which repositories are the people looking for? Then we have a diagram by architecture. So it's clearly only x86, 64, what most people are interested in. But this year, it's the first time that you actually see something else on this diagram. Before, it was only x86, 64. And with this slide, I'm already at the end. I try to be fast. So if there are any questions, I'm happy to answer about Mirror Manager, CentOS Stream 9, and Fedora.
On the chat, there's a question, would the best mirror also include archive repos?
Archive repos are from, I guess, archived distributions, Fedora 33 and older, and things like this. If this is the question, then yes, yeah. Okay. We track, so this is a Fedora questions mainly. We have a main mirror module for currently active distributions, Fedora up to Fedora 35, I think, is still on the main mirror. And all the versions are then moved to the archive, and then Mirror Manager points to the archive mirrors. And the number of archive mirrors is really small compared to the number of mirrors carrying the list of the active distributions or the maintained.
Right. So one of the observations that I made while using DNF update or DNF install is that the geographically closest location is the one that's kind of given the priority first. For me, it becomes the mirrors in Japan. So what happens is the latency is less, but then again, there are times when the latency is less, but the speed is suboptimal. So is there a system in place that kind of chooses between what should be given a priority, be it geographical location, latency, download speeds, something that lets you decide that?
So latency and download speeds are not part of Mirror Manager. We cannot measure them because they're only from your point of view. So we only do what data we have in the database, and this is basically net blocks. If somebody says your IP is close to my mirror, then we know that, and then it's ASNs, and then it's country. If there's a mirror in your country, you hopefully get that one, and if there's no mirror in the country, we try to add lists from the same continent. So not sure where you're located. So maybe I don't know. There's not a close mirror to you, which mirror manager can select for you.
So it's down to our DNF to actually decide which mirror they reach out to, and the balance between speeds and latencies, right?
Again?
It's down to a DNF, which the choice it is to select which mirror to go to.
Usually DNF doesn't select by latency or
Mhm.
speed. There is the fastest mirror plugin, but you shouldn't use it because
No,
this
it
totally
definitely should
breaks
not.
mirror manager.
Exactly. Yeah, understood. Thanks.
Any more? Yep.
Question is, you're agnostic about the use of DNF max connections, or like having a threshold, because there is some discussion ongoing about using like 10 threads or something like that. Do you have something to say about that?
So it's the DNF maximum number of connections which DNF makes. So it's an interesting question because I don't know if it's visible here. No, it's not. So, or is it here? Yeah. So there's actually here we have this max connections here, but this is hard coded to 1, so we don't do this. We used to have a field in Mirror Manager where you could set it, but it was actually, I don't know the history about it. It was set, it was hard coded to 1 before I took it over. And from what I learned about it, that it's not working as it's supposed to. I don't know if DNF looks at this or anything else. And if there's something which can use this, we can definitely change it to use the number the mirror provides. But I think, I don't know, DNF max connections, it's probably how many connections DNF makes to 1 mirror or to multiple mirrors. I don't know. Yeah. No idea really.
Okay, but it's something you are not discouraging to do from a client perspective, or?
No. So from my point of view, I have a mirror, and I'm happy to have as many connections as people want to make to it, because bandwidth, at least from my mirror, is not a problem, and usually a number of connections distributed amongst so many mirrors, it's also not a problem. So if people feel like they want to increase it, from Mirror Manager's view, I don't have any opinion on it. From a view of a mirror maintainer, I'm okay with it. So.
Thank you.
Anything else? Okay, thank you. So we managed to almost recover from our late start. So we'll take a short break, but we'll try to get back and let Fabian start at 1:15 so that we can, lunch is in less than an hour. So quick break, and if we get him started, then we'll all have a good lunch.
I was quite surprised that we had stream.org as a domain. So you can fix that. Wow, my stream.org. That's pretty impressive. Now I have to go find out if it's actually real. It's been 25 minutes since you presented that. Who knows what's happened?
Are you next?
Yes. Well, you can give it a try.
Yeah, I'm just not. It's not really
I
working.
know mine works because it was used for the first talk, so.
Okay.
Yes. Oh, yes, there is one. So I can.
I was gonna say, do you know what I'm doing wrong here? All I've done is plugged in. So.
So the only device that was not working this morning was an iPad. All the classical PCs are working. That's the reason why I don't know, it's good. It showed up, but and then it was gone.
Yeah.
It showed up for a second. I'm just wondering about the resolution that is set because maybe you see that the stream when going back to the projector, but it seemed that there was a problem. We were able to connect the thing from the iPad, but the projector was not. Yes, that's the issue.
Well, this is exactly why we did before. Can change that.
Maybe you can just lower the frequency of the. This is for second device, right?
Are you having problems getting?
Yeah, it's displaying, but it's not.
To lower to something like HD instead of full HD, just like that one 670, yeah. Let's see if that makes a difference.
So again, we're getting you.
Yeah, again, and not, yeah, it's an app one again.
It's an app?
Yeah, same thing as for, I guess.
Because it's Apple. it's Apple. It's never been tested on a non-Apple device.
It's not compatible with. It's a project that is not compatible. I don't know. Because you are catching the stream from So the HMI connection was there. And then the projector is like, oh, I don't know what to do with it. So if you, well, what we can do in most cases is that, your talk is in the afternoon, right? So
Yeah.
if you can export to a PDF and then we can use one laptop or another one.
Okay, because I can email it to you. That's the funny thing is, I work for Ampere and our laptops are so locked down. I can't put it onto a
USB?
Yeah.
Yeah.
It's hilarious because we just realized that. I went to do it and I'm like, what the hell? Yeah. Oh well, no. I mean, no, it's not because it's what I'm.
Yeah, of course. You know, yeah. If
I
you have some
purposely-
secret hidden notes.
Oh god, yeah. I can't even figure. Honestly, for our PowerPoint templates, I can't figure out how to get rid of the confidential. All of our stuff is, it's like, guys, if you bought, it's like NSA stuff. It's if you make everything top secret, none of it is. It doesn't make sense. Anyway.
I never use comments. The only thing I would probably do in the comment is like insert that joke.
I tried to do the opposite. I took.
1 minute ago, but.
Yeah, of course. Yeah, but.
Yeah, I mean, lunch is in 45 minutes and you're supposed to have a 45-minute slot, so.
I can make it shorter if needed. Really.
I don't want to rush you, but,
Because what I was told when we did it for, like, the reasons that I was very clear and next question. He just said that it did those things. So, are we going to do it?